Okay, we're going to do some notes on correlation. We're going to do linear regression equations and extension from our best fit lines from the other day. First one is something that we already saw. We saw this one the other day, and missed classes is X, semester grade is Y. So the equation of the best fit is here. So if we just went on negative 9 over 4, and that's change in Y over change in X, right? So this would be we lose the negative 9% for every 4 missed classes. Okay, and then of course you could say it's negative 2.25 if we divided it. So that would be lose 2.25% every 1 missed class, because now it's written over 1 every missed class. Okay, so the moral of the story is go to class. Y-intercept is 85, so if we miss 0 classes, the X value is 0, we have 85%. And this is on average. Doesn't mean you're not going to get an A, but this is based on this data. Okay. Next, we saw something like this the other day too. We talked about weak, moderate, and strong correlation and no correlation. So now we're going to put a number on that. It's going to be an R value. So the R is going to be the number. So if we have very strong positive, then you're talking about a linear scatter plot. It's definitely a line. So if you're talking about strong negative, you have a line going down. If we're talking moderate, maybe moderate positive, maybe it looks like this, right? Where we're definitely going up. Maybe that's weak, I don't know. It's between strong and maybe it's 0.5, right? And then what about if it's going down and it's kind of together? That's a little bit better, huh? So I would say negative 0.7 maybe. I'm just estimating here. What happens if we're going down and we're going down in general, but it's pretty weak, right? So now maybe we're at negative 0.2. And then what happens if there's no correlation? It's just a disaster. That's an R of 0. Okay, so we're going to put a number on them. So strong weak are going to be strong negative will be close to -1. Strong positive will be close to +1. Weak will be close to 0, and then we'll fall in there. So we'll get some values. Okay, grab your calculator. A couple of things we're going to do. So I'm going to actually go over to the calculator, so you should have your notepad out so you can see this. The first thing we're going to do is we are going to, let's find the calculator first, I guess. We're going to go to, so I'm at my home screen. All right, so a few things we're going to do. We're going to enter a scatter plot. So I'm going to go second stat plot. I'm going to turn it on. I'm going to, so this is scatter plot. I'm going to put my X's in L1s and my Y's in L2s. Okay, so that's no different from what we did the other day. One new thing that you see, the first thing there is we have to turn our stat diagnostics on. So I hit mode. Under mode is right next to the second. And I scroll down to stat diagnostics. Mine are already on. Yours might be on, they might be off. Stat diagnostics needs to be on. That's going to give us our R. Okay, so I turn that guy on, and then now I'm going to do the same thing that I did before. I'm going to go to stat, and remember I'm going to edit, and now I'm going to type in that data, which I have here, so you can take a minute to type it in. Again, my X's are going in L1s. Wait, I got the wrong data here. Oh, it is the same data. It's fine. We did this one the other day too. So this again is the age and the time spent gaming. 10, 15, 20, 22, 26, 30, 35, 40, 44, 43, 36. Okay. And now I'm going to put in the L2s. Again, if you had data there, probably should have said that. You go up to it, clear, enter, it'll clear it out. And now I'm getting 85, 75, 80, 78, 65, 60, 48, 38, 30, and 50. Okay. Oh, and 60. I missed one. 60 is that. So I know I have my 11 data sets there. Now remember, when we looked at this before, we went to, now we went to Zoom, and we went to, what did we do? We did Zoom Stat, which is number 9, and I can see my stuff. Now, if you got a rogue line in there, then let's go back to y equals. You should clear it out of your y equals, right? So the next thing I'm going to do is I'm going to take a look at my window, and I kind of like to change these 0 to 50. Counting by fives is fine, and then maybe I'm going to go from 0 to 100, and I'm going to count by tens. So I have a little better idea of what's going on there. And now when I look at my graph, there it is. Okay. Now, the next thing is the new piece that we're going to do. We're going to find our linear regression line. Okay, so I'm going to find a line that the calculator makes for me, and I'm going to go to, let's see, stat, but now I'm going to go to calculate, which is right here. So I have to scroll to the right, and I'm going to use this one. I know, depending on where you are in stat, sometimes they use number 8. We're going to use number 4, okay? And I hit 4. So here, now, if you read this, it says the X list is L1. That's correct. The Y list is L2. This is not a frequency table, so we're not concerned about that. But this is a big one, and you're going to want to follow the steps on your on the right here. Okay. So now with the cursor in the store regression equation, you're going to go to vars. That's variables, and we want y variables. And we're talking about functions, and we're going to put it in y1. So what we're going to do here is we are going to store the regression equation that it makes, and we're going to store it in y1. Okay, so I'm going to go, actually, let's look at the regression equation first, and we'll do that in a moment. So I'm going to calculate. Okay, so here's the deal. I have a slope of negative 1.444. I have a y-intercept of 102.96. R squared is for some statistics, and the R that we're looking for, that means this is pretty strong negative, 0.926. So if we look back at the graph, we can see that's a pretty strong negative. I have an R value of 0.926. So we're going to want to write that stuff down. So we should write that down on your right here. So I got to remember what it was now. I don't know what it was. What do I have? I had y equals negative 1.444 x plus 102.96, and I have an R value of negative 0.926, and I would say that's a strong negative correlation. Okay, now then this is what we're going to do now. I'm going to, rather than, because I can't get this exactly because they did a lot of calculations and I just wrote down, I rounded a little bit. Yeah, we could type that in, but we're not exact. So I'm going to plug this in to that spot. Okay, so let's find our calculator again. And here we go again. I'm going to go to stat. I'm going to go to calculate. I'm going to go down to number 4. We're going to use number 4. And now I'm going to store my regression equation. So here we go. Variables is right next to the key, the clear key, vars. And now I want y variables because I want to stick my equation into y1. And I'm talking about functions. We're working in functions, right? And then I hit y1. So it's going to put my equation right into y1. So we need to make sure y1 is cleared out. Now when I calculate, it gives me my information. I write down the important stuff. But now look here in y1. Oh, look at how many decimal points they went. And now it's there. And now I go to graph, and I have my nice regression equation. So now if I want to make a prediction based on a follow-up question might be, tell me, what do we expect a person that is age, Well, let's check for you guys. So let's say you're 17-year-old. So remember, there's a few different ways we can do that. We can second calculate a value, and I want the value of a 17-year-old, and I hit enter, and it gives me 78. So we would expect a 17-year-old, based on this information, to game for 78.4 minutes, and that's per, I forget what this is per. Is this per day? Um, uh, so you can make your predictions, and they're using this big thing, okay? So remember, the whole key is first we go stat, then we calculate. We're talking about a regression equation, and then I wanted to store that regression equation, and I went vars, and I want a y variable, and we're talking functions, and then I could store it in whichever one. This is going to send it into y1 or y2, and I hit that enter, and then we go from there. Okay, so hopefully we'll do a couple of those, and we'll do a little practice, and hopefully things are okay there. All right. And so here's the same one, and then we get that graph on our graphing calculator. Okay, let's try this one. I'm going to hit pause here for a second, and I would like you to enter test X into L1 and test Y into L2. And so enter that data now, and then I will be back in 1 second. Okay, so I have the data entered. I have my test X in L1 and test Y in L2. It says write a linear regression equation for the data, interpret the correlation coefficient. So here we go. Stat, calculate. Oh, wait, I gotta clear out my, I gotta go back to Y equals and clear that sucker out. Stat, calculate. Number 4. I'm going to store my regression equation in y1, which means I'm talking about variables. I'm talking about y variables. I'm working in functions, and I want to put it in y1. And now when I hit calculate, I get my info. Again, if you do not have r squared and r on your calculator, you need to turn your stat diagnostics on. So I'm going to write, what is it, 0.623 x plus 29.18. Okay, so let's find my piece here. And I have, so write the linear regression equation. Y equals 0.623x plus, what was the, I forget what the thing was now. And I can't find my calculator quickly. 29.183. Let's go with it. 29 plus 29.183. Okay, so this means we have a positive slope, right? Oh, I need the correlation coefficient. Oh, I didn't get that. Let's see, what do we have? Ooh, 915. That's a pretty positive one, isn't it? That's a positive. R equals 0.915. So that would be, it's a positive slope, so this would be strong positive. Let's look at the positive. I can spell. Okay, then it says predict the score to 87 on test X. Okay, so let's head back over to the calculator, wherever that sucker went. Let's look at the graph. So I'm going to go zoom, and again I'm going to go stat number 9, and I have that. I could change the window. I'm going to leave it for now. It's fine. But I wanted to, so this, you can see the very strong positive here. And then I want to calculate, second trace, a value when X was 87. So if you got an 87 on the first test, we would expect you to get an 83.4 on the second test. Okay, so 87 on the first test. What would you score on to 83.4 on test Y if you got an 87 on the first? So that's an ordered pair that falls on that line. Okay, so we had a slope of 0.623 and change in test Y over change in test X, and there we go. So again, not too bad, not too shabby. All right, we got one more here. In 1990, firework usage nationwide has grown as shown in the accompanying table. T represents the number of years since 1990. So here's 2001, right? Here's 1990, 1992, 1994. And this is millions of pounds of explosives. Holy cow. Write a linear regression equation for the data. So you've got, this is L1, this is L2. So you're going to get your linear regression equation. That means you're going to go to stat, and you're going to go to number 4, the linear regression, right? And then you're going to get the R, and you're going to get y equals mx plus b. Now we do have a little bit more work to do here. So again, I'm going to pause, enter the data, and we'll go from there. Okay, here we go with the last one. So I've got my L1, my year since 1990, and I have my firework poundage in here. So I'm going to go, remember, I still have my y equals in there, so I go to y equals, I clear that out. And now I go to I go to stat and to calculate. And again, we are doing number 4, linear regression. And I have x's in L1, y's in L2s. We're not worried about that. Oh, I got to do my regression equation. I'm going to put it into, I'm going to go stat, let's see, vars, variables, y variables. These are functions, y1. And now I calculate, and I'm going to write that down. Write that down on your paper, 8.187, 72.866. So I got y equals 8.187x plus, what was it, 72.6. So this would be, let's see, where did we go there? Where do we go? 72.86. And then an R value of 0.944. Oofda. That's pretty high. This was an 8.6. R of 0.924. Again, that's going to be strong. Positive, interpret the slope. Interpret the slope. Change in y. This would be, we're increasing by 8.187 millions of pounds per year. Isn't that great? And now we're going to work a little bit backwards. I'm going to have, this is actually y value is 99. So let's grab the calculator and see if we can figure a couple of things out. Number 1, I'm going to go zoom, and I'm going to go stat is number 9, okay? And if we're looking for a y value of 99, we can't input a value there, but we could look at the table. Let's go over to the table. Again, I'm at 10. I could scroll around. Remember, you might have to table set. Let's start at year 0, and let's count by ones. So I look at the table again. And 99 is going to be somewhere just after year 3, right? Just after year 3. So here's my tonnage based on that. But we don't have an exact value. I could change my table sets to decimals and start at 3, but we could do this too. What am I looking for? I'm looking for a y value of 99. Oh, if I put in a horizontal line at 99, oh, intersecting equations. When am I ever going to use this in my life? Oh, chapter 1. Here we go. Second, calculate. Intersection is number 5. First curve is my regression equation. Enter. Second curve is my horizontal line. Enter. Look at that. I get a, I have to hit enter again, and I get 3.2. So 3.2 would be years. 3.2 years since 1990. So at the beginning of 1993 is when we would hit 99 million pounds of explosives. All right. So again, we can put in a y equals and find that deal. So I got x equals 3.2. Whoa, what happened there? 3.2, which is 1993, and be what, 20% into 1993. So like March of 1993. Okay, good stuff. All right, we got homework now, so get to that. Remember, the biggest thing here is our how to find your y1 and how to enter that into the regression equation.